So let's start from where we left in the previous video. So after bubble sort, we are having selection sort, which is again another simple sorting algorithm. So in selection sort, the entire array is divided into two parts. One part is going to be the sorted part, and the other part is going to be an unsorted part. So let's understand how it works. It works by finding the smallest element in the unsorted part of the array and placing it at the beginning of the sorted part. So basically what is happening, we are picking the smallest element in the unsorted part and placing it in the sorted part. And this process continues till the entire unsorted part is empty and the sorted part is having all the elements at their correct position. In the bracket, you can see it's been written all largest or and you can do it both the ways. Either you take the smallest element from the unsorted array or you take the largest element from the unsorted part. In that scenario, you have to place it at the end if you are sorting in ascending order, right? The algorithm repeats this process until the entire array is sorted. Let's move on to the next slide. So it is also having the time complexity as O(n) square, where n is the number of elements in the array. So as the size of n means the size of array increases, the algorithm would become slower. Again, it is not very efficient for large or nearly sorted arrays. So let's now discuss the working of selection sort in brief, and after that you will get a clear idea of how selection sort works. Let's see how selection sort works. So over here I am having an unsorted array which is having elements as 20, 50, 10, 80, 60, 70. So this entire array is unsorted. It is not having currently, it is not having any sorted part. So in the first step, we'll be traversing the entire array and picking out the smallest element. So in the first traversal, we'll get 10. See, we'll compare all the elements in the array and find that 10 is the smallest. So what we'll be doing, we'll be swapping it with 20. Since it is the smallest, we'll be placing it in the beginning. So 20 will come at the place of 10 and 10 will go at the place of 20. So now my array is having a sorted part which is having 10 and the unsorted part is having 50, 20, 80, 60, 70. Again, the traversal would take place on the unsorted part. And in the unsorted part, in the second step, we'll find 20 is the smallest. So as we can see that we are having 50 at the second position. So we'll swap both of them, 50 with 20 and 20 with 50. Now 20 would also become the part of the sorted array. So now our array would look like this, where 10 and 20 are the part of the sorted array and 50, 80, 60, 70 are the part of the unsorted array. Over here you can see that the sorted part and the unsorted part. This process goes on until we reach the last element and we'll be having our final sorted array where elements are arranged in ascending order. So this was the brief working of our selection sort. Let's move on to insertion sort. So insertion sort is again a simple sorting algorithm. Over here it has been written efficient. You'll come to know why it is efficient in the upcoming slide. Let's first understand how it works. Insertion sort works by iterating over the array from left to right and inserting each element into its correct position in the sorted part of the array. I'll explain you what it means in a short while, but first understand that in selection sort, we had a sorted and unsorted part. Similarly, in this algorithm also, we'll be having an unsorted part and a sorted part, right? Further, the sorted part of the array starts with the first element and grows one by one in each iteration. The unsorted part of the array starts with the second element and shrinks by one element in each iteration. So basically what happens in this sorting algorithm is that the array is divided into two parts. There is a sorted part and an unsorted part. In the starting, you'll always have the first element in the sorted part and rest of the elements in the unsorted part. Every time a new element is picked from unsorted part and it is placed at its correct position in the sorted part. If you remember in selection sort, we used to pick the smallest element and keep it placing one after the other in a queue because we knew that the element that we have picked is going to be larger than all the elements that are currently present in the sorted part. But in this sorting technique, in the insertion sort, Every time we pick up a new element from the unsorted part, we compare it for its correct position in the sorted part and then place it in the sorted part. Let's move on to the features of insertion sort. So it does not use any extra space to sort the array. Space complexity is big O of 1. Secondly, it is a stable sorting algorithm, which means it preserves the relative position of equal elements in the array. If you don't know what is a stable sorting algorithm, then I have uploaded a 2-minute video on this topic, stable sorting algorithm. What is stable and what is unstable sorting algorithm? You can check it out. I will attach a link of it in the description. So let's move further. It is an adaptive sorting algorithm, which means it performs better on partially sorted or nearly sorted arrays. In selection sort and bubble sort we had studied, they are not very efficient on nearly sorted arrays. But in selection sort, it is considered a very efficient in case of a nearly sorted array. It has a time complexity of big O of n square in the worst case, big O of n in the best case, and big O of n square in the average case, where n is the number of elements in the array. So let's now understand the working of insertion sort. Let's move further. So over here I'm having an array of 6 elements: 20, 10, 50, 30, 90, 40. And on this array, we need to perform insertion sort. So first of all, as we discussed previously, start with the first element considered as a sorted subarray. So we'll be having a subarray with one element which is going to be the first element of the array, original array. Over here I am having 20 as my first element. I'll keep 20 in the sorted part as my first element. In the second step, compare the next element 10 with the elements in the sorted subarrays, shifting the greater element to the right. Now we would be picking up 10, which is the first element of my unsorted array, and insert it inside the sorted part at its correct position. See the third point. Insert 10 into its correct position within the sorted subarray, resulting in 10, 20, 50, 30, 90, 40. So this is our sorted part and this is our unsorted subarray. Now from the unsorted part, I would be picking up the first element 50 and put it inside the sorted subarray at its correct position. See the fourth point says the same. There's a mistake in this part. It should be 50 and then 30. So this is the correct order now, where we are having 10, 20, 50 in the sorted subarray and 30, 90, 40 in the unsorted subarray. Fifth point says that continue this process for the remaining unsorted element 30, 90, 40 until the entire array is sorted. And this is how our final sorted array should look like. So this is how the insertion sort works. We'll be having the overview of quick sort and merge sort in the next part of this video.